This video is to introduce you to our new motorized non-stop scaffolding. We think it's going to be a revolutionary development in the masonry scaffolding industry. It's reliable, safe, and cost-effective. You know, our customers have always told us how much they love their non-stop, especially for difficult to scaffold jobs. Cut-up jobs with lots of inside and outside corners, radius walls, short walls, etc., etc. And of course, straight walls are just a piece of cake. Some of them have also begun to use the high-dollar mast climbers, and they say the push-button lifting is their most popular feature. Now, I've become good friends with a lot of our customers over the last 40 years, and I picked a few who use both mast climbers and non-stop on a daily basis, and they agree that mast climbers are overkill for 2/3 of the work that their non-stop does routinely every day. But their men are addicted to pushing the button. So I asked them where they use each system, and the answer to that was very consistent. Non-stop goes on all the jobs that with a lot of cut-up work, no matter how high, even 300 feet high, and everything under 40 feet high, because it's faster to set up and they love not having to run all their walls scaffold high. The mast climbers go on long straight walls over 40 feet high, and some cut-up work if they own all the special bolt-on adapters for corners and whatnot. To us, the obvious natural solution was to take the best of both systems and combine them into one. And here we have motorized non-stop at half the cost of mast climbers. Colby and I are going to show you how simple the system is and how it goes together. Let's talk about the power system. You're going to have a hydraulic motor mounted on each winch to power it rather than cranking power. Then you're going to have a trunk line that I'm showing you right here that snaps onto each tower at the beginning of the job. Go ahead and hook it up, Colby. You'll hook on each winch, hook on the quick connectors, and then the quick connector at the end of this hose will go to the tower next to it. Okay, that's your basic unit. When you move the scaffold from wall to wall on the job, you're going to take these quick connectors loose at the ends and just pick up the scaffold with your forklift just like you always have. We're hooking up to the power unit here, but on the job, the power unit can go on either end of the scaffold, in the middle of the run, really anywhere you want it to go. But we're going over here to this power unit. Go ahead and start it up. All right, that's got a recoil starter, but our production units will have electric start and a recoil for a backup. We took a lot of time and designed this very carefully. For instance, all the fittings, the entire system, it only snaps together one way. There's no way you can hook it up backwards and have a problem where the system won't work. Now let's look at the cranking of it. On this scaffold, we simulated the weight of a pallet of block, 2,800 pounds, which is a little more than 500 brick, with a couple of bins of our mason's outrigger brackets. And then when you have your strongest man cranking as hard as he can, it generally takes him about 20 seconds to crank the scaffold up 8 inches. Here with the motorized unit, go ahead, Colby. It only takes about 15 seconds. Now, for safety and simplicity, our system operates one winch at a time per power unit. You can put more power units on there if you want to, But if you wanted to run 100 or 200 feet of scaffold with one power unit, you could. You'll still have plenty of time to raise the scaffold. Your bricklayers will never fall behind. Looks good, Colby. Now we're going to take this weight off the scaffold and show you how it would be lowering the scaffold down. You know, normally you would lower it with just manually, but you can also use this hydraulic motor to lower the scaffold too. While Colby's doing that, I'm going to show you a few close-up shots of how the system is put together. Now, in actual use, the lever and the valve will have a guard over it to protect it from accidental operation and from any damage. Go ahead and let that one down over there, Colby. There's no way to pinch your fingers or anything like that. This is the way they would normally lower the scaffold if they were cranking it down. They would hold that dog up with their thumb and crank it down manually. These two winches sound different because they're prototypes, and the anti-reverse is made just a little bit different on each one. Now, when you're designing a system like this, you've got to have plenty of power to crank it up, and even when it's overloaded, you have to be able to crank it with 4,000 pounds on it. The most you'll normally put on it is going to be about, like I say, like a pallet of block, about 2,800 pounds. But then we have to plan for any kind of problem that may occur, like go ahead and put that 2x4 in there, Colby, like a brick or block or something gets caught in the scaffold that would keep it from going up. Go ahead. We still have plenty of cranking power, but if something gets caught like this, you notice he's still holding the handle. It has stalled the winch out. All right, let go, Colby. And you can go back and forth with the handle. You can see he goes back and forth, and it's just stalled out. That's the beauty of well-designed hydraulic systems. So this is our final prototype. We're ready for production. As a matter of fact, we've already begun production. And this new winch is compatible with all our non-stop heavy duty made after 2000. So this is the first informal introduction of this system to all of our established customers. You'll be getting this link from us for this YouTube video. And we would encourage you to put your pre-order in for full systems or just upgrade the winches. You can upgrade the winches, get the trunk lines and the power unit, and you're good to go. Thanks for watching.